So we have yet one more example to look at that shows off parallel streams, and I do this for a couple of different reasons. It's an interesting program, not unlike what you're doing for your assignment, and it also lays the foundation for a wonderful apples-to-apples comparison between parallel streams and completable futures for I/O-bound processing, which is kind of cool. So we're going to talk about something called the ImageStreamGang app. And this supplies several parallelism frameworks. We've got parallel streams and completable futures underneath the hood. They use pools of worker threads, which could be the fork join pool, will be the fork join pool for the parallel streams case, and can be the fork join pool for the completable futures case. We'll see that there's more variation and more flexibility available for completable futures than with parallel streams. Another thing that this program will demonstrate is the benefits of integrating object-oriented and functional programming paradigms. So we're going to be showing a really cool approach where the overall structure of the program is object-oriented, and then we've got functional programming for the behaviors that do the parallel computation. And we also demonstrate how patterns are used to kind of emphasize the key roles and responsibilities in the design of the app. And patterns, of course, are things hopefully you learned in earlier courses here at Vanderbilt for proper design and trying to leverage the wisdom of people who've been there before and learned from the School of Hard Knocks. So the user interface for the ImageStreamGang app is implemented with various Java features. This app combines the StreamGang framework with Java streams and parallel streams and completable futures to download, transfer, store, and display images in a couple of different ways. And as usual, just for fun, we have a sequential version kind of as a baseline to show, sort of how slow things can be. And then we have various parallel approaches that will demonstrate the benefits you get from parallel processing. And it also is cool because, as we'll see, we can compare and contrast the parallel streams approach, which is a fundamentally synchronous approach, with completable futures, which is a fundamentally asynchronous approach. So here's what the interface looks like. You have a little box where you can put a bunch of URLs separated by commas. So the user is prompted for the list of URLs to download, and then they can supply the list of URLs, and then they can go ahead and click the download icon, and that will then download all those images in one or more threads of control, and then it'll apply a bunch of different image filters to it. So here's sort of the regular version, here's the grayscale version, there's other versions as well. Much like your program, you can have all kinds of different filters to apply. Typically multiple filters. There might be 3 or 4 filters per image, and you'll see why that is important later. As the filters are applied to the images, they are then stored persistently in order to make sure that they're around even if the phone gets powered down. So they're stored in persistent storage. There's a bunch of modern Java features here. So the parallel streams version is the one we're going to look at right now. And you can see it's fairly short, but it's very powerful and very scalable. There's also a completable futures version, which, as you can see, is longer and turns out to be a bit more efficient, but it's more complicated. So you can have the real short version that works pretty well, or you can spend more time and implement a more sophisticated version that scales better, but is harder to write and harder to read. We use various other foundational Java features like lambda expressions and method references for stuff. So we have this for the GUI. So once you're done processing things, you can basically print the results on the user interface thread. And that is arguably more concise using the foundational features than doing things like anonymous inner classes, which is the old school pre-Java 8 way of doing things. There's a whole pile of patterns that are applied in this app to try to simplify different aspects of its design. Some of the patterns are the so-called Gang of 4 patterns. That's this book here, Design Patterns, Elements of Reusable Object-Oriented Software. Other patterns are so-called POSA patterns, pattern-oriented software architecture patterns. A lot of them come from POSA 2, which I was the lead author on, and POSA 3, which were some of my former grad students. And so I'll go through these very quickly, and then we'll sort of see how they get applied throughout the example. So some of the most essential patterns to the design of this solution are pipes and filters, which we've talked about before. This pattern's been around for a long time. You see it with things like Unix streams, Unix System 5 streams, pipelining on the Unix command line shells with the bash shell or TC shell and so on. And the future pattern as well, which gets used very heavily here for asynchronous computation. Those are kind of POSA patterns. Pooling, of course, is used. There's pools of threads. That's a POSA 3 pattern. Template method, which is a good old gang of 4 pattern, where you define some of the steps in a method in a base class, and you can selectively override various sub-methods by inheriting and overriding from the base class in these subclasses. We also use decorator and factory method. Factory method is used all over the place. In fact, your latest assignment, when you look at it, you'll see we have a bunch of factory methods for various reasons. Decorators, which are ways of being able to take a base computation and then wrap things around it. So we use this for the ability to apply filtering or transformations to different images before we store them. And then we also use other more, sort of tactical patterns like singleton and command at various places throughout the implementation. So lots of good stuff, lots of good patterns. If you know patterns, if you know gang of 4 patterns, if you know POSA patterns, the design is fairly straightforward and easy to understand. Speaking of understanding, this is a non-trivial program. It's got a lot of classes. Some of the programming logic is pretty cool, but you have to understand it. So we're going to look at it from a couple of different perspectives. We're going to look at it from its patterns. We're going to look at it from its data flows. We're going to look at it in terms of the detailed code. And each of those things is intended to give you a different perspective on what's actually happening. And I find that very useful, especially with parallelism, because it's sometimes hard to just look at the code and really have a deep understanding of what's happening. So watch this lesson. You might want to go back and watch it again. Visualize the data flow. We'll look at some pictures like we often do, and take a look at the code to see how everything works. And obviously some of these things may also give you some insights for writing the programs that you're doing, because they're not completely dissimilar. There's similar themes, although the implementations are a bit different. Okay, so that's the overview of the ImageStreamGang example. Now we're going to start walking through its pieces one by one.